Hello. Yep. So welcome back after the awesome presentation by Jeff. Okay. So today I'm going to introduce Ali. Ali is currently the CTO at Beamable and was previously a founding engineer at Disruptor Beam, which is a Boston-based game studio. He has shipped large licensed games such as Game of Thrones Ascent, Star Trek Timelines, and Walking Dead March to War, to over 20 million players in his time as a game developer. And today, it empowers the studios and teams of all sizes to build and operate games at scales with Beamable. Apart from this canned introduction, what I can assist you or we can tell you and assure you is that Ali is a great storyteller. He'll take you to the worlds of games and basically introduce you to vector search and how they have done it. Awesome.
Test. Yeah. So these guys pumped me up way too much. We'll see how this goes. But thank you all for showing up, and I hope you enjoyed the presentation. So Tales of Mythos is a little game that we made at Hackathon. So I'm Ali. I'm the CTO at Beamable. I've been making games for just over 10 years now. And feel free to reach out. So how did this journey begin? So some of you are familiar with Tech Week. Tech Week is a conference that's held in San Francisco and LA by A16Z. And our CEO at Beamable, John Radoff, looped me in and said, hey, let's go to Tech Week, but also let's participate in this generative AI virtual worlds hackathon. And of course, I was like, group project with the boss. That sounds fantastic. But let's do it. So we did, and we, lo and behold, ended up winning first prize, which was a big surprise and a delight, and got to learn a lot of really cool stuff in the process. If you ever get a chance, by all means, check it out. LA at that time of year is awesome. So what did we want to do? We wanted to build a project that basically could leverage AI and play to its strengths. So AI today, the LLMs and the technology that's out there, has a lot of strengths, but it does have some pretty notable weaknesses. So we wanted to build a project that could play to the strengths of AI. And so we figured, well, a lot of people are generating pre-production assets with AI, doing it ahead of time before shipping the game. Maybe we could do this in real time. Maybe we could do this at runtime and have a fully dynamic world. And just a quick show of hands here. Who's played Dungeons & Dragons here before? Who's played D&D? Don't be shy. We're cool now. OK, if you don't get a chance, find somebody in your social network. I'm sure somebody, have them play a game with you. But what we wanted to do is try to bring that immersive experience of Dungeons & Dragons to the virtual medium, which is here until now been done imperfectly because it's very open-ended, right? And when things are open-ended, well, you can't really do that in video games typically because you're constrained by the medium and the programming and so forth and so on. But with AI, maybe we could. And we had one day to do it. So that was fun. And again, nothing gets the creative juices flowing like a group project with the boss. So we did manage to deliver something pretty cool. So this was our team. So you can see yours truly on the right-hand side and John Radoff, our CEO, on the left-hand side. And then a couple people that we met over there at the Virtual Worlds Hackathon. Dolce, who did all of the visual generative AI for like art. And Fabrizio, who did the music also. So the whole project, like the sound, the visuals, everything was generated with AI. And this is what the game ended up looking like. This is just a screenshot of the game, and you can see that there's basically a virtual world. The character portrait in the top left is my character. That art was generated with scenario. The character description was also generated. And here's what it looks like. Here's how it plays like. So start off the game with basically a little tarot card character creator, where you select a couple of tarot cards, and it'll generate an asset for you. And I'll just let that play for a couple of seconds. But what's happening right now is it's generating in real time all of the assets. And you can see we've got a description, the character sheet, the visual art, the name of the character. All of that is generative AI happening in real time as you're playing. And then what happens is once you have your character, you get dropped into this world with a basic prompt that sort of sets the stage. Hey, you're in a tavern, of course. Great place to begin a Dungeons & Dragons campaign. and you get to play the game in a text-based adventure game. And it'll regenerate the assets around you in real time as you play. So if you say, go to the docks, or go to the village, or get into a fight, you'll get visuals that get generated at runtime as that's happening, right? I'll post a link to this video afterwards. You can watch the whole thing, and you can see. But it gets really fun. I got into all kinds of crazy adventures. I ended up getting into a brawl at the tavern. I summoned a demon and burned down the village, and then I lost the game. So there's all kinds of fun stuff that are very, very open-ended that can happen. So let's go to the next one. So how do we do this? Here are some of the technologies we used. So Unity for the game engine, Beamable, our company, we provide back-end technology so that game developers can focus on their differentiator, namely making a really fun game. Turns out making games is hard because not only is it fun, but it's also technically very challenging. So you use a variety of technologies to go faster. Anthropic, that some of you may have heard of, OpenAI competitor, they just got a bunch of funding. They have a large language model that's super cool. Scenario, which allows us to generate visual assets. Blockade Labs to generate skyboxes, so virtual environments that sort of wrap your surroundings. MongoDB Atlas, of course. OpenAI for embeddings, and then Midjourney for some of the user interface aspects. Cool, so what is the architecture? Just getting into the meat of it. So basically, this is a general diagram of what things look like. We implemented a client-server model with a large language model generating the story and gameplay within the context of a game engine. And then we created the server with Beamable. That's the game backend. And then the various bits and pieces like the generative AI graphics with Scenario, a bunch of others. But fundamentally what's happening is the LLM generates an XML payload. How we're able to make sense of all of this is we gave it a very long prompt and said, here are the rules. Don't tell the player what to do. Generate an XML payload. It should contain a room name. It should contain like the characters in the room, the interactable items, all of this stuff, and honor this format every single time. And this is very interesting because it sort of introduces a new mode of programming where all of the gameplay logic can be just described rather than coded. Instead of having to write every line, say, okay, if this, then that, you just tell the LLM, hey, here's how you're going to advance the game, and just do this, right? And that's what happens. And this is a little sequence diagram of what happens actually down in the weeds, right? So you've got the game front end, which is Unity. A player input is sent to the chat. The back end does a whole bunch of stuff. So the database in this case is MongoDB with Atlas. It'll query the list of things that have happened. It'll get back a historical list of campaign events. So like, Ali spoke with the bartender and ordered an ale, and he went and spoke with the rogue in the corner, and so forth and so on. And all of that stuff in narrative format gets stored in the database in separate documents as the story advances. And at the end, if you were to take all of that and order it by date, you would get something that reads very much like a novel, right? And so that's returned, that context is returned, and then that gets appended to the latest player prompt. So if I then said, okay, leave the tavern, go outside, what we send the LLM, namely Anthropic, is a giant block of the entire history. Like, Ali spoke to the bartender, ordered a nail, everything going back to this precise moment, and then we tell the LLM, go ahead and advance the story accordance to this entire history and context and so forth and so on. So we send that prompt, and we get back an XML formatted payload that says, hey, here's what happens next. You left the tavern, the village, it's dark, you see some random villagers walking around, there's a well in the middle, so forth and so on. It describes that environment. We take that description of where you now are, we feed it to a different model, the Blockade Labs Skybox model. It will then generate an image asset, return it back to Beamable. Beamable then sends a notification to the client, go ahead and render a new environment, so forth and so on. And same for any other visual asset. So you can see that the blue lines over here are the communication with the Blockade Labs Skybox model. The green lines are communication with Mongo, and then the red lines are communication with the Anthropic LLM, okay? So what does this LLM architecture look like? This is sort of, I know it's a very busy slide. What you can see here is, on the left-hand side, a description of what the text input looks like, such as, you're going to be a dungeon master in this D&D game, Anthropic, and we will be using rules according to SRD 5.1, use my campaign specifications. You can get very detailed. And this prompt is like several paragraphs long. It's describing exactly like, here's how you should behave, here's the rule sets to know, and Claude knows about Dungeons and Dragons, so it knows a certain amount of the rules, and there's certain characteristics and the bestiary and the monsters that exist in the world, and so forth and so on. Then we take that and we append the latest information. We feed it into the game backend, and we get back this payload over here on the right-hand side. So that's an example of the XML payload you get back: the room name, characters, music, the story. And that story bit is what gets saved in the database each time as a campaign event. And that becomes sort of the next bit of context that gets continuously re-injected into the prompt. So that's the, Jeff mentioned earlier, the retrieval augmented functionality, the generative AI. That's what that is. It basically takes that and keeps building this giant context and keeps injecting that context into the LLM to basically get the next part of it. And then that gets rendered into the front end. Cool. So then what do? We take pieces of this XML payload and we feed it to different models to get back visual assets. So the character sheet, that gets fed into the scenario model to generate the character portrait. So we'll get something like, hey, this is a dwarf, that is a barbarian and, has got a gray beard and so forth and so on. Feed that into scenario. Scenario comes back with the character portrait. We then take that character portrait and we render it. Similarly, for the story, we get that from the LLM. That goes into the chat UI, and we actually have two flavors of text: one that is sort of the story, and one that is like the dungeon master commentary. So you get like a story that's like very narrative, never breaks character. Like, hey, you left the tavern and you encountered some spiders, and you get into a battle or so forth and so on. But then there's also a separate commentary where the DM is like, okay, well, what do you want to do now? Like, you've encountered these spiders, you can run away, you can do this, so and so. So the whole game is encapsulated as part of this LLM, behavior. And then, of course, the background, the Blockade Labs generative spatial graphics, that description at the very bottom, a rough-hewn inn and tavern filled with simple wooden tables and so forth and so on, that gets fed into that model, and you get back a nice visual representation of what that all looks like. Cool. Why did we use the Claude LLM rather than OpenAI, GPT 3.5 Turbo, or GPT-4? Well, the 100,000 token context window is why. So for those of you that don't know or haven't had a chance to play around with this, LLMs have this maximum length that you can feed them before they throw their hands up in the air and they say, sorry, can't give you an answer, you've exceeded your token limit. I ran into that painfully with the earlier versions of the GPT 3.5 Turbo before they raised their context limit. But then Claude showed up, Anthropic's Claude, and they're like, hey, guess what? It's 100,000 tokens. You're not going to run out. Of course, has echoes to the Bill Gates, sort of never going to run out for like whatever it was, 1 megabyte, never need more than 1 megabyte. But they came out with a 100,000 token context window. What does that mean? That's the Great Gatsby. So you can feed it the equivalent of the entire Great Gatsby novel and ask it questions about that, and it will give you responses, which is awesome for a Dungeons & Dragons campaign, because those can get really, really long, and you can get up all the details. Like something I did 5 campaigns ago, 5 days ago, or whatever, can still be fed into it, and you get a contextual response. Like, hey, remember when you met that character way back when? Well, that character's in this scene now. So it makes for a much richer, immersive experience that can call back to previous experiences. It's very immersive, right? It's also really good at formatting XML for some reason. So that's one of the recommendations in the prompt crafting. And then cohesive story and player identity, unique stories each time. That's sort of one of the main reasons we used Claude. So I mentioned earlier something about, okay, well, hey, this is kind of a new, interesting way to build gameplay logic. Instead of having to code every part of gameplay logic, you could just tell the designer, hey, you want this to behave slightly differently? Go update the prompt. Don't come bug me, the engineer. Don't come tell me like what to do. Like just go edit the text that says here's what your behavior is, and the game will just adapt. And so that's what this new semantic programming concept is. The idea is that instead of having to code every line, the LLM is essentially a narrative program that is tunable and adaptable, and you can make changes to it whenever you please. And then it's augmented with vector databases to do the retrieval, augmented generation, and so forth and so on. And you need a whole sort of back-end stack in order to properly lead it to do what it's doing. But it's fairly general, and very sort of flexible architecture. And voila, now you have a game that you have got vast world to explore and interact with. It's visually and narratively rich. Game devs can change the gameplay rules and context by modifying the starting prompt. And this can lead to really small teams doing really incredible things. And this is just the beginning, right? Like you can imagine all kinds of amazing developments where you're not just generating a skybox, you're actually generating actual 3D geometry, or you're generating characters with their own history. So like when you start to think about how this can grow and extrapolate and become what is the next generation of generative AI looks like, this starts to feel like a potentially really interesting approach. But wait, not so fast. There's a lot of problems with this, and I ran into those. And I banged my head against my desk during the hackathon trying to figure out what to do. But this is where Mongo, Atlas, and Vector Search, and actually before what led me to this talk today is I had discovered on GitHub somebody had started using Atlas Vector Search. It hadn't been announced yet, and I just copied the code and was like, Atlas has vector search, let me do that. Instead of going and learning Pinecone and learning some new database, I already know Mongo, I'm already using Mongo, all of my data is in Mongo, can I just use this? And it worked, and then I reached out to the Mongo folks and I was like, hey, I've got some questions about this. This works, but like X, Y, and Z, and they're like, is this public? Like this wasn't supposed to be public yet. And I was like, well, I'm using it, so anyway, so that was cool. And but there's the main challenges were latency. So generative AI graphics at runtime slow, up to 3 minutes to make a single asset. So again, depends on how many people are using it, depends on the models. But 3 minutes is really slow. If you're playing a game, you're waiting for 3 minutes, you're gonna rage quit. Cost. The assets are they can be generic, and it's still very costly. So you're making these calls to generate all these assets. If you're running an actual game, as some of my colleagues have found out at various points, like it can completely tank the economics of a game if you're paying for these generation all the time. So it's a nice hackathon project, but could you actually make a real game based off of this? And then token limits. So 1,000, 100,000 token limit is great, but like, you're going to exceed that too at some point. So how do you manage those limits, and how do you make sure that you're not shutting yourself out from better models? Like Anthropic Claude was great, but maybe GPT-4 comes out with some really big improvement, but I have to work within the constraint of a 16,000 token limit. So you don't want to shut yourself out from model quality and speed. So what if we could reuse previously generated visual assets that match our description? So make fewer calls is one option that you could do. So that means less cost, and that means less waiting. So how about we generate everything at runtime, but we reuse those assets. So if somebody else comes up and says, I've got a dwarf that's a barbarian with a gray beard, maybe we don't have to generate that again. Maybe we just use something that's already in the database. The other thing that we could do is filter down the prompt context to only what is relevant to this particular moment. So instead of going back 10 campaigns, or whatever, just grab the stuff that's relevant to this particular question. This becomes important in multiplayer experiences as well, because then if you've got multiplayer, then I might have my historical context, and you might have your different historical context, and you might have a different historical context. So it's like, how do we just select the slice that's needed to answer this particular question and advance the story? So this is where vector embeddings come in, and vector databases become useful. So you've heard about this. You've heard about vector search. It's been mentioned in a couple of the talks before here. But fundamentally, what's a vector embedding? It's pretty simple. You're just converting the meaning rather than the form of text, images, or sound, right? So into a numeric representation that can be readily compared. So for example, in a traditional text search, if you search for the word cat, well, cat is closer to caterer than it is to feline. And that starts to get you to understand, that's the difference fundamentally between meaning and the sort of similarity of form. So vectors compare meaning rather than word anatomy, right? Cool, so this is an example of what that might look like, right? So just at a conceptual level, you get text. You feed it into a text model. So OpenAI has one such model. Somebody mentioned that Hugging Face has some as well. There's a bunch of embeddings models. In this case, I used OpenAI. And you get back, you just give it the text, in my case, but it could be images and sound, and you get back this array of numbers, right? And that will basically give you, if you plot it in a multi-dimensional graph, you get sort of certain nodes are closer to others, right? And what's a database? What's a vector database? Well, it just stores vector data and is able to search by vector. So you input a vector. So you take, let's say, say you use the dwarf with a gray beard and so forth and so on. You take that, convert it into a vector, feed that into Mongo Atlas, and say, give me something that looks like this. And then Mongo Atlas gives you back, something that looks like that. Cool. And then this is, somebody mentioned this already, the data preparation stage and so forth. So basically transform into an embedding. You also get the queries on one side and the data prep on the other side. And then you get the nearest neighbor vector result. So this is what an optimized version of that graph looks like, right? So instead of going game front end, game back end, straight to the generative AI, you go to the database first and you say, okay, is there something that looks kind of like this that already exists in the database, whether it's a visual asset or whatever it might be, you get back a result, and oftentimes you can cut down the time quite a bit. So I drew a box around the sequence part over here where you see the blue lines, where the visual assets are the most time consuming. So you can see here, instead, basically first check if there's a match found, and if there is one, you just return right away. If not, if there's no match that sort of abides by the level that you're interested in, then you go and you generate the asset. And when you generate it, you don't just return it, you generate a vector embedding for it, and you store it in the database for future use. The nice thing about that is if you have enough players playing, the first players will have a slow experience, but the more people join, the more you get a diversity of assets, and the more sort of your cost reduces and your latency improves over time. Cool, so here's a sample document. Prompt, a pair of crumbling stone doors engraved with strange hieroglyphs leads into the ancient temple ruin. This is an actual thing I encountered in the campaign that I was doing. And you can see here we've got a style name, the file URL for the skybox, and then the embedding, the actual vector array of numbers. Here's an index, the index definition. So when you create the actual search index, you basically just say, hey, here's a number of dimensions, here's the similarity, and here's the type. The dimensions is informed by the embeddings model. So that 1536 number might be familiar to some of you. That's the OpenAI embeddings dimensions. That's what that number is. And then you create the index. Somebody mentioned this earlier. This is a really nice thing that I harped on the Mongo folks for a little bit, annoyed them with my emails, but they added this functionality pretty quickly, which is the ability to create these indexes directly from the driver, which is awesome. It means you don't need the Atlas API key. You don't need to go to Atlas to create the search vector index. You can just do it lazily from within your application, which is super, super powerful. And then the search aggregation, this is when you actually want to search. This is what it looks like. And you just pass in your query vector, and then you get back a set of results. Here's an example of the results. So this is top 2. You'll see that you get a subset of the document. In this case, I filtered it to just the file URL and the prompt. And then you get a score, which is generated by the Mongo Atlas search. So in this case, I set a threshold of it's got to be greater than 0.9, or else don't even bother returning the result. That's a number that you should tune based off of your use case. And voila, it resulted in 80% less waiting. It went from 35 seconds of wait time on average to about 7 seconds measured end to end, which 7 seconds is still somewhat slow for gameplay aspects, but 7 seconds is workable. And it's something that we expect that will continue to decrease over time. So final thoughts, generative AI is fun. It's expensive. It's sort of slow. Your mileage may vary by use case. For some cases, you might not want to reuse assets. But vector search is key to cost and latency. So getting clever about it and making sure to optimize is super important. And then Atlas Search can help without increasing infrastructure service area. That was my point. So at Beamable, we deliver a cloud compute platform to game developers. We don't want them to have to learn a whole bunch of new technologies. Our goal is to allow them to focus on the fun. And so reducing the infrastructure surface area is absolutely vital. It's important to allowing people to be creative and focus on the things that matter to them without having to learn a whole bunch of new things. So that's it. Any questions? I want to open it up, and we've got about 5 minutes, so
You said that you asked the LLM to generate like an XML document for you. What was that experience like? Was it always consistent? Did you ever have issues with it generating, different, XML schemas, stuff like that?
Yeah, great question. Surprisingly consistent. That doesn't mean 100% consistent. You definitely need to handle the resilience cases, the error cases, retry it. That does happen, especially on the faster models. So like Anthropic has two models, one that's I think the latest one, Claude 2, and then Claude Instant. Claude Instant is substantially faster, but it's also substantially dumber. So as far as the XML payload results, it would make mistakes. It would, and then of course my program would be like, oh, I can't parse this XML, and then it's like, so there's a little bit of stuff. There are things you can do at the prompt level and at the program level to hedge against that.
Thanks.
Good question. Please.
As things improve along the embeddings generation, you chose a specific text model, right?
Correct.
Say that changes a year from now, 2 years from now, and you've got all this content that's in all the embeddings. What's your plan, or how do you plan to deal with that?
That's a great question. So the question was, hey, embeddings models will change. What do you do with this large body of documents that you've generated embeddings for, which is no longer valid, right? I haven't thought that far, honestly. But thinking about it right now, I would say the main thing that, the naive thing you would do is just revectorize everything. I think there's going to be more technologies that sort of take that niche and just do that lazily. And I think we'll probably see closer collaboration between embeddings and embeddings models and databases, where maybe that happens transparently behind the scene. But
You can keep using that.
the simplest thing, yeah, exactly. Simplest thing is keep using your old models. Yeah. Keep using your old model, or revectorize everything, or create a new vector search index, and then you have two embeddings fields. Versioning the embeddings fields might be a good way to do that. Yeah. We figured it out. Who else? Don't be shy. Please.
I wonder how you address any kind of user context in this history cache that you build. Because there might be some settings which are so specific to the user that you can't do a semantic search on that.
Yeah. It's tricky, honestly. The campaign event stuff, I struggled with that. Building out the historical context. At first, it was kind of like, okay, well, let me just include everything. The user prompt and the response. I'm just going to shove it all into context and include it all. Did not work well, which is why I opted for the more narrative structure, where I was like, okay, I'm only going to save the narrative sort of novel-like aspects, because that made it that played more to the strengths of the LLM, where it was like, okay, it's just like they keep using the Great Gatsby as an example. It's like, well, let me give it something kind of looks like the Great Gatsby. Here's sort of a bunch of narrative structured stuff, and I'm going to ask it questions about that. So I think it's going to be domain specific, and you're going to have to grapple with that, but that is one of the more challenging aspects, is constructing the context history. So you're spot on. Wish I had a better answer for you. Anybody else? Questions? Awesome. Well, it was a pleasure talking to you all. I hope you found that useful, and feel free to grab me at the hall, or reach out Ali at beamable.com or on LinkedIn. So thank you. Enjoy the conference.